Okay, we're going to do a review for the quiz that we have on 10.2 and 10.3. So here are some review problems for 10.2. Alright, let's start off with something kind of simple. We've got the square root of 60. Alright, now what we want to do is make sure that we go ahead and make a list of our perfect squares. Okay, usually 144 will get us to where we need to go. So I'm looking at this list and I want to find one of these numbers that will go into 60. So I'm looking for a perfect square times another number. So looking at this, I'm thinking, I know that 4 will go into 60. If I do that in my head real quick, 4 will go into 60. We are looking at 15 times. So I know I can't break 15 down with a perfect square. So it's 4 times 15. The square root of 4 is 2, so it goes to the outside. 15 stays under the radical. It's not a perfect square. You cannot take the square root of it perfectly. Alright, so let's go to one where we have to multiply. Sorry, this should be number 2. So I have square root of 7 times square root of 14. So the first thing I can do is I can multiply any radicals I want, unlike addition or subtraction. So I just need to do 14 times 7. So that's going to give me 28 and then carry the 2, 98. So I'm looking for a number on the perfect squares list that will go into 98. The highest perfect square I can get is 49 and then times 2. The square root of 49 is 7. It comes to the outside. 2 stays under the radical. Alright, let's keep moving on. Let's do one more here. Let's do 3 square root of 12 times 5 square root of 6. Now, you got a couple options here. You can break down 12 first before you multiply. A lot of students just go ahead and multiply and then simplify with the perfect squares towards the end. So multiply your coefficients. That's going to be 15. Then multiply the two numbers under the radical. 12 times 6 is going to give us 72. I'm looking for a perfect square that goes into 72. I do want the largest perfect squares here on this list. And the largest perfect square that goes into 72 is 36. 36 times 2. Okay. So then I have to say, okay, well, what is the square root of 36? It's 6. I'm going to take that 6 and multiply it to the 15, leaving just the 2 here under the radical. 15 times 6, that's going to be 30. Carry the 3 is 90. 90 square root of 2 would be my final answer for that one. Alright, hopefully you have these perfect squares listed. I'm going to switch papers. Okay, let's do another example from 10.2. This is example number 4. Square root of 56, m to the second, n to the fourth, p to the fifth. Alright, so this one we still have to break down the 56 using our perfect squares list. Alright, I'm looking for a number that goes into 56. That's a perfect square. I'm going to go ahead and just write my variables down. Alright, so will 4 go into 56? 4 times 14 is 56. So 4 times 14, I'll write that there. The square root of 4 is 2. 14's got to stay under the radical. I can take the square root of m squared. Remember, the number here is 2, we just don't write it. When you're trying to take the square root of a variable, just divide their powers, and whatever might be left over, if it doesn't work evenly, stays under the radical. So, 2 into 2 is 1, so there's 1m. 2 divided into 4 is 2, so there's 2 n's, n squared. And then 2 into 5 goes 2 whole times. That should be a 2 there. Sorry, that's not very clear. And then 1p gets left over. So let me rewrite this. Now, technically, when we go from an even to an odd power, these should have absolute value symbols around them. All right, now let's try one with a fraction. So I have the square root of 2/10. First thing I would do is see if that fraction can be reduced under that radical. It can. Let's change that to 1/5. Now, a radical can be distributed to the numerator and denominator. That gives me square root of 1 over square root of 5. Remember, we have these like grammar rules of math. It's not good to leave a radical in the denominator. So I'm going to multiply the numerator and denominator by the square root of 5, whatever the denominator is. Keep in mind, I'm not changing this because this is the same thing as multiplying by 1. Square root of 1 times square root of 5 is square root of 5. Square root of 5 times square root of 5 is exactly what we wanted to happen, is the square root of 25, which is 5. So any radical times itself is just the number. So now I have it completely simplified with no radical in the denominator. Let's try a different kind where we have to use conjugates. Alright, so in order to simplify this one, again, we don't want that radical in the denominator. So we have to multiply by what it's called the conjugate. So it's just the denominator with its opposite operation sign. So if it's minus, it's going to be plus. Again, remember, what are we doing? We're still just multiplying by 1. We're not changing anything. We're keeping it balanced. Alright, so when I multiply the 3 to this binomial, it has to go to each one of them. So 3 times 5 is 15, plus 3 times the square root of 2, which is 3 square root of 2. Now, when you multiply by conjugates, instead of doing FOIL, you can actually do a shortcut because the middle terms will cancel out. You can just do first, and then you can do last. It'll always be minus. Square root of 2 times square root of 2. Remember, like this one up here, when you multiply a radical times itself, it's just the number. So square root of 2 times square root of 2 is going to be 2. Simplify this out, basically combine like terms in the denominator, and I get 23. And that would be our final answer. So this is the review on 10-2. You can also try practice problems from your homework.